In this example, it's just like the last one where you want to write this as a negative exponent, and this one you want to write as a rational exponent and then find the derivative. So if you feel like you know what you're doing, pause the video and try that now. So with x squared in the denominator, you can rewrite that as x to the negative second, and then your derivative would be negative 2 moves in front, and then you take 1 away, so it'll be negative 3. And then rewrite this as a fraction since that's how it was given to you. So negative 2 is on top because it has a positive exponent of 1. And then you've got x cubed on the bottom because it had a negative exponent. So that would be your derivative. Over here, your radical can be written as a rational exponent where the squared is on top, but the index of the radical is your denominator. And then your derivative, you would move your 2/3 in front, and then you would take 1 away. Now when you take 1 away though, you need to get a common denominator, so 3/3. And so you're going to get negative 1/3 for the exponent. Now write this as, let's write it as a fraction and as a radical. So 2/3 is 2/3. Since x has a negative exponent, it's going to be in the bottom. And since it has a rational exponent, that means x has a radical. A cubed root is what that is. So you've got 2/3 cubed root x. In example 3, find the equations of the tangent line and the normal line to the curve y equals x square root x at the point 1, 1. So what we're going to do is find the tangent line, which requires the derivative to find the slope of the tangent line. And then we're going to find the normal line, which is just the perpendicular line to the tangent line. So once we find the slope using the derivative, we'll just do negative reciprocal of that to find the normal slope. So go ahead and rewrite this as an x with one exponent, and then find its derivative. So what I mean by write this as an x with one exponent is you want to consolidate your variables down to one variable. So right now I've got x to the first, and this square root x is x to the 1/2. Since they have matching bases and you're multiplying, you can add exponents. These are all just algebra properties. We haven't done any derivatives yet. If you get a common denominator for 1, this is 2/2, and you can add your fractions. You're going to get x to the 3/2 when you combine the two variables together. Then you're going to find your derivative. So the 3/2 goes in front. Then you take 1 away from your exponent, which is 2/2 as a common denominator, and you're going to get 1/2 as the exponent. It is easier to write it as a radical. So you're going to have 3/2 square root x as your derivative, which is the slope of the tangent line. Now, if I want to write the equation of the tangent line, I'm going to plug in my x value. Square root 1 is 1. 1 times 3/2 is 3/2. So this is the slope of the of the tangent line. So you're going to have y minus the y value equals the slope, x minus the x value. And then distribute your 3/2. And then add 1 to the other side to get y by itself. If you add 1, you're really adding 2/2, common denominator, so negative 1/2. So that's the equation of the tangent line. Then they asked also for the normal line. So you're just going to take this slope. Slope 2 is going to be negative 2/3, the negative reciprocal of the one you got earlier. And do the same thing again. Y minus the same y value equals this new slope, x minus the same x value. Distribute your negative 2/3. Add 1 to the other side. Common denominator is going to be 3/3 plus 2/3, which ends up being 5/3. So that's your tangent line. This is your normal line. You've got derivative rules for combinations of derivatives, same as your limit rules. If you've got derivative of a constant times a function, you can bring the constant in front, and then so you can kind of factor out your constant, and then just do derivative of the rest of your function. When you're adding two functions, you can do derivative of the first plus derivative of the second. When you're subtracting, you can do derivative of the first minus derivative of the second. In examples 4 and 5, we got examples as to having a number in front, a constant. So here there's a constant of 3 that you can bring in front. Here there's a constant of -1 you can bring in front. And then here you've got an example of where you're adding multiple functions together, making this polynomial. So let's do these together. So using that property, when there's a constant, you can bring it in front of your derivative. So you would do 3 times the derivative of x to the 4th. And then you would take the derivative of x to the 4th, which you move your 4 in front, and then you take 1 away from the 4, so cubed, and then at the end you can multiply those back together. So 12x cubed. So over here I can bring that -1 in front, and then take the derivative of my x, which ends up being a 1 moves in front, and then when you take 1 away, you're going to have 1 minus 1 in the exponent, so it's going to be x to the 0. Anything to the 0 is 1, so you have -1 times 1, which is -1 for your derivative. You do not have to bring numbers in front, so in the pink here I'm showing you could have just left the 3 and done 4 times 3 is 12, and take 1 away from the 4 to get 3. You don't have to do all that. Again, you don't have to bring the negative in front. You could have just left it. And then, so you would have done 1 times -1 in front, take 1 away, so you get 0. And then x to the 0 becomes 1, so just -1. Here I'm going to show you the long way just so you know how it can work, and then I'll show you a shorter way, just like on the last one. So what we can do is split these into 1, 2, 3, 4, 6 derivatives. So derivative of the first term plus derivative of the second term plus derivative of the third term, and so on. Okay, then we can go through and move constants in front. So this 12 can move in front. And this is just me showing you how the properties work on that slide that we talked about. Sometimes what we're doing here, even though this is longer, this is taking longer than other methods, we might want to use this method later on to help us with the harder derivatives that we're going to see. So we're just kind of trying this method on an easier problem right now. You can leave the 5 or you can bring the 5 in front. I'm just going to leave the 5. So now I'm going to find the derivative of everything that's in your parentheses. So this will be 8x to the 7th. This will be 5x to the 4th. This will be 4x cubed. 3x squared. X will just become 1. And derivative of a constant is always 0. And then just go ahead and multiply coefficients. So we end up getting 8x to the 7th. We get 60x to the 4th, -16x cubed, 30x squared, -6. So that would be your derivative. The faster way would be just, you don't need to split them or move numbers in front. You can just move 8 in front and take 1 away. So 8x to the 7th. 5 moves in front, you get 60. Take 1 away, you get 4. 4 moves in front, you get 16. Take 1 away, you get 3. 3 moves in front, you get 30. Take 1 away, you get the 2. 1 moves in front, and you get -6. Take 1 away, you get 0, so no x. And then 5 has no x, so it becomes 0. Many times the problems on quizzes and tests is that students don't understand the directions. So make sure you are reading the directions and understanding what they are asking. Here it says, find the points on the curve, this curve, where the tangent line is horizontal. So we've got a curve, tangent line. Every time you see tangent line, you need to think derivative. So the slope of the derivative would be the slope of the tangent line. And we want to know, where is the tangent line, the derivative, horizontal? So tangent line means, or derivative means slope, and we want it to be horizontal. So what would a horizontal line, what slope would a horizontal line have? It would have a slope of 0. So they want to know what points will make the derivative equal 0. So we're going to find the derivative and set it equal to 0. Let's do that now. Again, the derivative is the slope of your tangent line. So let's find the derivative. You're going to have 4 in front. Take 1 away from 4, you get 3. Bring 2 in front, you get 12. Take 1 away from your 2, you get 1. There's an x to the 0. So if you bring 0 in front, you just get 0 because it's a constant. Constants go away. So this is your derivative. Now, so this is the slope of your tangent line. The tangent line is supposed to be horizontal, so they want to know, when is this 0? So set this equal to 0. We can factor out a 4x. That's going to leave me with x squared minus 3. You're going to set these equal to 0, each one. So if I divide by 4, 0 gives me 0. If I add 3 and take the square root, positive and negative radical 3 give me a horizontal line as well. So we got 3 x values for this one. Now, because it said points and it didn't say find the x values, and it said points, we really should take these x's and plug them in to get ordered pairs. So because we got 0, we can say the point 0, 4, because when you plug in 0, you get 4. 0, 4 is a point on the curve. You also should plug in your radical 3's. So I got 0, 4. And then I plugged in plus or minus radical 3 just because these are even exponents. And I knew the negative and the positive doesn't matter because even exponents cancel negatives and keep things positive. So I just did plus or minus radical 3 to the 4th, which means it's squared once to get rid of the radical, and then it's squared again to make it a 9. Here, when you square, just the radical goes away, so you get 3, and then you end up getting negative 5. So you've got 3 points, 0, 4, and then you've got positive radical 3, negative 5, and you also have negative radical 3, negative 5 as your points.